Welcome to a brief lecture on chemistry. We're going to look at atoms, chemical bonds, water and its properties, and acids and bases. And that will be what's covered under this brief lecture. As you can see, put yay on here because, as we all know, people love chemistry, right? Alright, first thing we're talking about is the atom. Sorry, let me continue. So, what is an atom? Well, an atom is the basic unit of matter. Atoms make up everything. When you look at the periodic table, which we're going to look at in a minute, all the elements on there are at its most basic level an atom. So what does an atom look like? Well, an atom's going to have a nucleus, and you're going to have, and actually we're going to use blue for protons. Protons are positively charged, and they are what we call a subatomic particle, and they're found in the nucleus. We also have neutrons, which are a neutral. So think P for protons positive, N neutral. Okay, and those are all found in the atom. Now when we start looking at atoms, or at elements, each element has a specific number of protons. That's what signifies it as that specific element. Now around the nucleus you have electron shells. Okay, you have all these orbits of different energy derived electrons. So there's different levels of energy. We're not going to get into all those. What you need to know for this course is you're going to have these electron orbits, and we're really only going to deal with the first three. And in the first three, you can have 2 electrons in this one, and actually let me use red for this. 2 electrons in this one, 8 electrons in this one, and 8 electrons in this one. And this one can vary. Okay? But for our purposes, we're not going to get any bigger than that when we look at molecules, so you need to know that. That's referred to as the octet rule. Atoms like to have a full outer shell and 8, octet referring to 8 there. Okay? Some atoms don't get to that second shell. So those are the amount of electrons that are allowed. They don't necessarily have that many, but that's the amount they're allowed in those orbits. Okay, and there's a variety of energy levels. The further you get away from the nucleus, the higher the energy. Okay, the higher the energy. The closer, the lower the energy of the electrons. Okay, this will be very important when we get into looking at chemical bonds because the electrons is what causes the bonding. Okay, let's look at the periodic table. So here's a small picture. It doesn't show the entire periodic table, but we're not going to go any larger than actually these first 2 rows here. We're not going to touch really on any more than that, except actually, well, we actually will get those ones too. So we'll hit some of these ones in the middle here, but not a whole lot. Okay, so we won't go any further than what I'm showing you there with atoms. Now, on the periodic table, it's arranged based on atomic number. Okay, we have hydrogen, which has 1 proton. It's the atomic number 1. Okay, this one up here is actually oxygen. Oxygen has the atomic number 8, so it has 8 protons, and it's a neutral atom, so it also has 8 electrons. So it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. The 2 white ones here or how many more it can add to that energy, to that electron orbit. It can have 2 in the first and 8 in the second. It only has 6, so oxygen can get 2 more electrons, and we'll talk about how they do that as well. So that's how they're arranged on the periodic table. Make sure you know atomic number. It's the number of protons. There's also an atomic mass, which doesn't show on here, but in oxygen case it would be 16. The atomic mass would be 16. And that's AMU equals 16. And what that is atomic mass is protons plus neutrons. So in this case, if the atomic mass was 16, and you know you have 8 protons, 16 minus 8 gives us 8 neutrons. Because a lot of atoms have different forms of it. So for example, carbon has what we call isotopes, as other elements do as well. Hydrogen's one, where they have different numbers of neutrons. For example, if this one had 9, the atomic mass would be 17. Okay, if they have different types of atoms with varying types of neutrons, the proton's always going to stay the same. But if there's different atomic masses, different numbers of neutrons, then the It's just a different form of the same atom, same element. It's just called an isotope. Okay, so isotopes just have different numbers of neutrons. Okay, so make sure you know atomic number, make sure you know atomic mass, make sure you understand how to figure out the number of electrons, protons, and neutrons. And on exam, you will be given the periodic table. All right, next we're going to look at chemical bonds. So what's the importance of electrons? And what do they do? How do these atoms come together to make the molecules that we know, like salt and sugar and those kind of things? How does this occur? Well, there's three types of bonds that we're going to talk about that make this happen. The first one being ionic bonds. Okay, and in this case, what happens is, for example, we have sodium and chlorine here. Well, chlorine has 2 electrons in its first shell. It has 8 in its second shell and 7 in its third shell. So it can add 1 more to its third shell. Okay, it can add 1 more to its third shell. In order to do that, it has to get one from a different atom. So what happens is in this type of ionic bond, sodium has 2, 8, and 1. So it could have 7 more here. Well, would it be easier to gain 7 or get rid of 1? Well, it'd be easier to get rid of 1. So what happens is sodium gives its negatively charged electron to chlorine. Now when it does that, chlorine gains an electron and now has 18 electrons. And normally chlorine has 17 protons. So if it now has 18 electrons and 17 protons, it has a net charge of negative. It has a negative net charge. Therefore chlorine now becomes negative. Sodium lost an electron and it has 1 more proton, so it becomes positive. Now they have opposite charges and they attract. So you end up with a sodium chloride compound, which is our table salt. The sodium molecule will actually come over, and think of it like a magnet. When you put a positive and negative side together, they come together and hang out. Okay, they are attracted to each other. And that's what the ionic bond is. Okay, it's an attraction of opposite charges due to the transferring of electrons. The electrons are given up. They're not shared, they're given up. The next one we're talking about is covalent bond. Covalent bonds are sharing electrons. So in this case, instead of giving one up, they share them. So there's no change in charges. They just hang out. They share the electrons together. And I've shown you an example here. It's a water molecule. Oxygen, again, can gain 2 electrons, as we saw in the periodic table. They have 6 in their outer shell, so they can gain 2. Hydrogen has 1 in its outer shell. It can gain 1 more because it only has the first shell. Okay, it can gain 1 more electron. And it can gain 1 more. So what happens is they come together and they share their electrons. So hydrogen gets 2 here, and then oxygen gains these 2. So hydrogen gets 2 total, fills its outer shell. Okay, let me get rid of this. And then oxygen needed 2 more, so it gains these from hydrogen and shares those, and it has its full outer shell. And that's what we call a covalent bond. They are sharing the electrons. And that's your most common bond you'll see. And it's the strongest. Ionic being the next strongest. Now, the last bond here we're going to talk about is hydrogen bond. Now, first we've got to figure out why hydrogen bonds occur. Well, if we look at this water molecule here, oxygen is very electronegative. So just imagine, think of it like an electron hog. It wants all the electrons. So what it does is, even though they're sharing, oxygen actually pulls these electrons closer to itself. So you end up getting more negative particles on this end over here. And so that makes it more negative over here. And actually I'll do that in red. Makes it more negative over here. If more negative goes that way, this end becomes more positive. So what you did is you created 2 different charged poles. One end's negative, one's positive. We would call this a polar covalent bond. If it didn't happen, it would just be a non-polar or regular covalent bond. But in this case, it would be a polar covalent bond. Well, when you get a bunch of polar molecules together, the opposite charged ends are going to orient towards each other. So what would happen is this negative end over here would bond here with this negative end, and really what it is it's a bond between the negative oxygen and the positive hydrogen. And these would actually orient towards, if we had another oxygen here with hydrogens, it would orient this way. Okay, Okay, and you would have these bonds created between water molecules, and that's actually why water has so many unique properties that make that are very valuable to life. Now let's talk real quick about water in life. Water is considered the universal solvent. Okay, a solvent meaning it dissolves items. It doesn't dissolve everything. It dissolves things that are hydrophilic. Hydrophilic means hydro water, philic loving, so it will dissolve in water. Salt is hydrophilic. Hydrophobic, they do not dissolve in water. Hydrophobic does not dissolve in water, it's water-fearing, so like fats, lipids. So if I poured oil in here, they would separate. That's hydrophobic. But water is a very important solvent, and here I've shown how it dissolves a molecule. What happens is, for example, if we put salt in here, salt is what we'd call the solute. It's what's being dissolved. It goes into the solvent. And when it goes in there, the polar molecule of water actually pulls the charged sodium and chloride apart. Remember, sodium's positively charged, chlorine's negatively charged. So the negative chlorine is going to go to the positive hydrogen side of the water molecule, and the positive sodium is going to go to the negative oxygen side of the water molecule. And so it dissociates like you see over here. And because of these unique properties of water's polar molecule and its ability to dissociate, we're able to dissolve things in our body. Water is also able to hold, to absorb a lot of energy, a lot of temperature. That's the reason we're able to keep, moderate climate on here. It's also why in the desert where there's no water, it's really cold at night, because there's no water to absorb the heat from the sun and keep it warm at night. Water has a lot of very important properties for life. Finally, we're talking about acids and bases. And again, this is a brief lecture, so I'm kind of moving through this. You can listen to the other lecture as well. Acids is any type of molecule when it dumps into an aqueous solution, meaning a water-based solution, it releases hydrogens. For example, hydrochloric acid. This is an ionic bond. Chlorine's negative, hydrogen's positive. When they get dumped in, they separate or they dissociate. So the hydrogen gets peeled off of the chlorine. Anytime that happens, we call it an acid. It creates more hydrogens, which actually decreases the pH. Anytime you get more of these in the water, you decrease the pH, making it more acidic. Okay, making it more acidic. So you would lower the pH below 7, depending on how many there are. The pH scale is just a measurement of the amount of these hydrogen ions in the solution. If there's less, it's going to be more basic. If there's more hydrogen ions, it's going to be more acidic. Basic is anything that accepts these hydrogen molecules. So imagine you got these hydrogens in here, and let's say we throw in sodium hydroxide. They will dissociate because this is an ionic bond, and this OH minus will actually pick up the hydrogen protons that are floating around that make it acidic, and they'll absorb those and take them in, and that will decrease the hydrogen ion concentration, therefore increasing the pH, making it more basic. Okay, and that's a quick snapshot of acids and bases. Make sure you know pH is the measurement of the concentration of hydrogen ions. Less hydrogen ions, more basic. More hydrogen ions, more acidic. Let me repeat that in a different way. More hydrogen ions decreases the pH below 7. Less hydrogen ions is going to increase the pH possibly above 7, depending on where the concentration is. Alright, that's my brief lecture on chemistry. Make sure you get into the textbook, get into the quizzes, and study for the exam.